Very warm greetings to you all again. This week we are going to be looking at worksheet 9. Worksheet 9 is based on graphs, and again it is application of simultaneous equations, or basically the points of intersection. The learning outcome for this one says students be able to understand the concept of finding the points of intersection by solving equations simultaneously. Now this time we are going to be looking at linear equation with a quadratic equation, right? Now quadratic equation is a U-shaped graph, and we have a linear graph which is a straight line. So basically we are going to find the points of intersection between a U-shaped graph and a straight line. Okay, let's have a look at example 1. Find the coordinates of the points of intersection of the parabola y equals x squared minus 2 and the straight line y minus 2x is equals to. Now this time, looking at the equations, you should be in a position of identifying what kind of graphs they are. This one here has a power of 2. X only has a power of 2. So this is the equation of a parabola or a quadratic function. This one here, y has a power of 1, x also has a power of 1. So this one here is the equation of a straight line. For all these types of equations whereby we are looking at two different kinds of equations, the only method that I will advise for you to use is the substitution method. So we are basically going to substitute one equation into the other. Okay, it can go vice versa, whichever one you prefer. Now this one here, y is already a subject of the formula, so I can do this substitution. Y is equals to x minus 2 from here can be taken in place of y into the next equation. So let's do that. In place of y, I'm writing this one here, x squared minus 2, that's the y value here, goes in place of y. The rest of the parts of this equation remain the same. Minus 2x equals 1. Now this forms a quadratic equation, another quadratic equation. Keep in mind, all quadratic functions can only be solved by equating it to 0, and also ensure that we are writing terms in descending power order. Okay, this also tells us that we are going to have at least two solutions. So let's rewrite that. X squared remains. I'm going to write the x term after that, so minus 2x minus 2, and bring this 1 this side, minus 1. We take 1 the other side, minus 1 cancels. Negative 2 minus 1 is a negative 3. Now this equation is equal to 0. After this, we are going to use the methods of quadratic solving. We can either use type 1 quadratic factorization to solve, or we can also use the quadratic formula. Okay, keep in mind, you can also use the completing the square method if you know how to use it. Well, nevertheless, let's work this out. Can we have numbers multiplying to give us negative 3 and adding to give us negative 2? Okay, we do have numbers, right? Our numbers are negative 3 and positive 1. Negative 3 times positive 1 is negative 3. The same numbers, negative 3 plus 1 gives me negative 2. Yes, they do. So my two brackets are x minus 3 into x plus 1 is equal to 0. When I've got two brackets equating each one of them to 0, x minus 3 equal to 0, x plus 1 equal to 0, and then solving it further, plus 3 cancel, x is equals to 3, minus 1 cancel, x is equals to minus 1. These are my two x values. Now keep in mind, we haven't finished the solving yet. I need to work out the y values. So either of the two equations can be used. Let's use the first one. Y is equals to x squared. I'm going to put the first x value in place of x. So 3 squared minus 2. 3 squared is 9. 9 minus 2, 7. Using the second x value, y is equals to second x value is -1. The use of brackets is very important in this case. You don't use brackets, you won't get the right answers. -1 squared is +1. 1 minus 2 is a -1. My answer is -1. So the 2 points where these two types of graphs meet are at 3, 7 and -1, -1. So these are my 2 points of intersection. The same thing can also be seen in this graph. If I am graphing the two equations, this is my parabola. The parabola of equation y is equals to x squared minus 2, and this is the straight line graph. Y minus 2x is equals to 1. As you can see in this diagram, this line cuts the u-shaped graph at two positions. This one is 3, 7 and -1, -1. Right? These are the two coordinates where the points of intersection are. The graphical method can also be used for all simultaneous solvings. Okay, but you have to be very accurate. If you look at these graduations, okay, they are equidistant and no numbers are being missed. All the numbers are being put up in all directions. Okay, and then it is being done on a grid. So if you draw your graphs on a grid using accuracy, then only your answers will be correct. Okay, and the other disadvantage of using the graph is that when we get decimal answers, okay, it is very hard to actually identify the correct decimal value. If it was, let's say, 1.53 or 1.78, it is very hard to show on a small piece of paper. Okay, so the recommended method is still the substitution, but if you're confused with that, the graphical method is always there for you. Let's have a look at example 2. Says y is equals to x squared minus 4 and y is equals to x minus 2. Using substitution, we can also equate the two y's together. Y is equal to y. So let's do that. Y is equals to y. The first y equation is x squared minus 4 equals the second one x minus 2. Now again, this time our highest power is 2, so therefore it is a quadratic equation. I need to bring all the terms to one side only. X squared, the x taking it that side becomes a minus x, minus 2 becomes a plus 2, so -4 plus 2 is -2 is equal to 0. Okay, so whenever we come to situations where the highest power of x is 2, we need to equate the equation to 0 in order to solve. From here, we can always use a quadratic formula, or I can use type 1 quadratics. Okay, let's see if it is possible. -2 times 1, -2 plus 1. Does it satisfy the condition? -2 times 1, -2. -2 plus 1, -1. Yes, it does. So my two brackets are x minus 2 into x plus 1 equals 0, and we do the solving similar to what I did previously. Equate each bracket to 0. This is called the null factor law. And then solve for x. X is equals to 2. X is equals to -1. These are my two x values. I need to find the corresponding y value. Let's use this equation this time. So y is equals to x minus 2. X value of 2. 2 minus 2 is 0. Second one, y is equals to -1 minus 2. -1 minus 2 is -3. So my two coordinates are 2, 0 and -1, -3. So upon solving these two equations simultaneously, these are the 2 points of intersection that we have. Thank you everyone. You can do the exercise questions from here on.